Bismillahirrahmanirrahim, Madam Emilia. This video here is for you, your solution to quiz number 2. 3 questions in quiz number 2. The first question says, resketch the tilted circuit. Alright, I know you're not able to do this, but you should be able to tilt your paper or something like that. So once you do that, pretty much it's a straightforward circuit. Okay, optic illusion. Okay, so once you have that, you can sketch a circuit. Okay, that's the 5. That's the 2 ampere over there. Let me make a mark. Just put. Okay, and then that one here is a 2 ohm with the I not going this way. And then you have your sign. I'm here now. It's in series with 2 ohm. Plus minus, that's a 4 volt. Okay, and then you will have, now I'm here, then I reach this X here, this X here, so it has 2 branch, one emits 1 ohm. Okay, now a lot of you get this 4 ohms confusion. Alright, so those of you who actually notice that there's a 4 ohm over there, okay, you will not get that mistake. So one of it is going to 1 ohm, another one is here, is going to 2 ohm, and then finally it met with 5 ohm. Now I think 1 or 2 students forgot to put this one at the 3 ohm. So once you have that, there's the 3 ohm over there. I said 3 but I write 2. And then there's a 2 ohm over there. That's the 5 ohm. Okay, so many of you, I think not many, I would say little of you have the confusion where you actually put your 4 ohm over here. Okay, and then some of you missed out this bit. Okay, but all in all, a lot of you actually got the answer for number 1. So 3 marks, you have it there. So if you did one mistake, what I did is I just deduct 1 point over there. Okay, so maximum if you get mistake is 2. But if you do it completely wrong, that's 1. Okay, but I would say most of you get either 2 or the correct answer 3. Next bit is the question of using superposition. Okay, I think 2, 3, 4, maybe 4 or 5 students, I cannot remember, but using source transformation. Okay, so please do not get confused. The question asks for superposition. Alright, it's not source transformation. Or maybe there's only one student who's doing source transformation. But a lot of them who did superposition get that problem. This one here. Remember I mentioned to you, you turn off all except 1. It means you should be only having one source at a time. Only one source at a time. Alright, there's one student who do 2 circuits. One, it turn off the current, another one, it turn off the 2 voltages. So it has 2 circuits, so he got 1 circuit that is correct, representing the current, and then the other circuit, he or she draw this. For some unknown reasons, okay? So you should not be having only 2 circuits. Remember, you turn off all except 1. You only have one source at a time. You do the number of circuits. You have to sketch the number of circuits depending on the number of independent sources. So that is superposition. Alright, so please don't get confused with source transformation. I'm gonna get the black pen back. So now let us do this. So for this question, okay, I'm looking at one circuit correct, 1 point, okay, and the rest is for your calculation. So if you sketch 3 circuits that are correct, you already back 3 points straight away. So I'm just going to do for 2 ampere by 2 ampere. So turn off, voltage source becomes short circuit. So I'm just going to draw that circuit here. Oh, madam is on leave. Going for a holiday tomorrow, but I haven't packed my bag. So that is your circuit. Okay, by 2 ampere, this is what you have. You turn off voltage, become short circuit. Turn off voltage, become short circuit. That's the 2 and the 3. That's the 1 and the 4. And that's the 2 and that's the 5 and that's the 2. 2 ampere. So the question here asks for, let us call that I1. Okay, so what is I1? I1 is the current passing in this direction through 2 ohm. Okay, now what you have to do is, you know that you can do current divider. Okay, let me just put a sketch. For current divider you can use it if there is a current source and only 2 resistors connected to it. Only 2 resistors connected in parallel with it. Okay, then if you want to find this I, we take the opposite I divided by total, so I1 equals to opposite resistor R1 plus R2 multiplied by the IS. So sometimes you have a current source, sometimes you just have this. You have a known value current entering the node. Okay, one thing that you have to take note is this. Okay, so the problem with Shafak dropped the negative sign. Okay, so when you do your, in this circuit here, let me just sketch the new circuit. I'm just going to add 1 to 4. 1 to 4 is 5. I'm going to add 2 with 3. So 2 plus 3 is another 5. So my new circuit, I'm just going to sketch it so that everyone can actually see the whole process. So now you have your 2, and now what is this bit? Series. Now this one here, I'm just going to put the value. That one, the 5, that's the 2. What about this bit here? What is this? This is these 2 resistors connected in parallel. So 5 is in parallel with 5. Okay, so when you put into the numbers, you will get you get 2.5. Oh, I actually have written the answer somewhere, but my kids took it. I don't know where they put it, so I have to recalculate everything now. So there you have it. So that one is 5 in parallel with 5. I hope it is clear. Okay, now I'm looking back at this I1. So when you do current divider, this is what happened. When you do current divider, your current is thinking it's going this way, current this way. Now you look at this current here. This current will enter here and it goes that way. Okay, so hence it's negative. So by current divider, I1 is negative of opposite resistor, which is 5 over, this is the opposite resistor over total resistor, 5 plus 2 plus 5. Okay, everything else you can actually just do that if you want. Okay, you said, madam, you said only 2 resistors connected in parallel. Yes, you can do that. You can just do 7 ohm there. You can just replace this with that. This is okay. And then multiply with IS, which is 2 ampere. Okay, so once you plug into your calculator, you will get negative 1.05 ampere. Alright, now let us look at the next one. Now how about by 4 volt? Now by 4 volt, what happened? So turn off voltage becomes short circuit over here. Turn off current becomes open circuit, so your circuit just have to go here. Okay, so I'm just taking back this circuit here, putting it here for everyone to see as reference. Let me put it over there. Alright, so by having 4 volt only, then turn off current become open circuit. That one here is a 5. That's the 2 over there. I'm keeping my 4 volt this time, so that's a 4 volt. Okay, and then going down, that's I'm gonna just add 1 and 4. They are in series, that's a 5. And then turn off current, becomes short circuit, that's a 2 and 3. And what do you notice? You notice 2 and 3, they are in series. So you can do 2 plus 3 equals to 5. What's the current again? So this time the current is here. That's your I. Let's call that I2. Because in the end, superposition, you have to add I1, I2, I3. In this case, there are 3 because there are 3 independent sources. Alright, now, what do you have to do? What's the easiest way? You notice that if you get R equivalent, you know that if this is IS, what do you notice? I2 is in fact negative of IS. So now you know that you have to find IS. You know that IS equals to VS over R equivalent. But what is your R equivalent? So R equivalent equal to, now 2 and 3, they are in series, you already add it up. It is in parallel with 5. 5 in parallel with 5, and then they are in series with 5 and 2 plus 5 plus 2. What did you get it? That's 2.5 plus 7 gives me 9.5. Hey, I said 5, I write it. You know, there's a sign of old age, you know. Ya Allahu Akbar. Ya Allah. Bless me with good age, you know. Tak nak nyanyuk lah, takut. Now IS, therefore IS equals to VS. In our case, remember it's negative later, so it's okay. We just do IS equals to 4 over 9.5. So you plug into your calculator, what did you get? You will get 0.421. Therefore, I2 equals to negative 0.42. Don't forget your unit. Alright, now let's go to the next one. The next one is, let me just have that one there. The next one is by 5 volt. Same way. I'm going to repeat the same step. You know, each time when I discuss quiz with students will always say, Allah madam, senang sebenarnya. Yes, sebenarnya sangat senang. Okay, so always think that it is not difficult. Okay, but don't let your guard down pula. I mean, you still have to practice. You still have to practice. So that's a 1, that's a 4, short circuit 4 volt, open circuit 2 ampere. I have my 2 over there, I have my 5 over there, and I have my 3 ohm over here. Now the question is what? The question says I want my I3 now. So what do you notice? What do you notice? What do you have to do? What do you notice? So you're saying that, madam, if I have the current here, I know this is going to be IS if I do that. And I can use current divider, but wait a minute. This direction is opposing this direction that's coming into this junction. So I know that I3 is negative. Am I right? I hope everyone actually seeing this. Okay, so another way of doing things is you could say that, madam, instead of I'm finding my IS, can I do source transformation? Yeah, you can do source transformation over here. You will get the current. Okay, once you get the current, you can actually get the same thing, current divider. Again, it's negative though. So it's really up to you which method you like. So I'm just going to practice a source transformation. Okay, I want you to bear in mind, source transformation, you do the obvious first. 2 and 3, they are connected in series. You can add it up first, isn't it? 1, 4 in series. Let us just practice our source transformation doing this question. Alright, just gonna do that. because I have the luxury of the time. So that's a 5, that's a 5 volt, and this one is also 5, that's a 2, that's a 5. So I'm going to transform this bit, just for argument's sake. I want to do source transformation. Okay, let's just do that. So when there is a voltage source in series with a resistor, we can transform it to become a current going upwards, arrowhead, positive sign, that is in parallel with the resistor. So this resistor here is here. Okay, so everything else is the same. What do you notice? Oh, madam, it is in series. Current in series, current of the same path is the same. Can I add it up? Yes, you may. Very good. So that is 7, that one is 5, and that one is 5. Okay, but madam, you said current divider can only have 2. Yep, you can only have 2. You can only have 2. So what do you have to do? That's your I3. So you have to do what? I said when there is a current, you want to find out that path, do not touch this resistor over here. So what you can do? You can add these two here. 5 in parallel with 5. Okay, so therefore by current divider, oh yeah, you know we have to do this. 5 times 5. I think we did just now previously as well. You will get 2.5 ohm. So by current divider, I3 again is negative because this current is going this way now. Oh, subhanallah. The current is going this way and this way after you add these two in parallel. So I3 equals to negative. Opposite resistor. What is the opposite resistor? It's 2.5 because you added these two. So opposite resistor. And then over total resistor. Total resistor is 2.5 plus 7. Multiply by, oh, we forgot, what is the value of this current? By Ohm's law, I equals to V over R. Your V is 5, your R is 5, that is a 1 ampere. So multiply by 1. So plug into your calculator. You should be getting negative 0.26. So to finish the question off, therefore the question asks for I0, isn't it? I0 equals to I1. In this case, it's I1, I2, and I3. Remember, I used I1, I2, and I3. Oops. Therefore, I0 equals to I1 plus I2 plus I3. Okay? And then what do? You just have to put the numbers together, right? So what's the number? It's negative 1.05, negative 0.5, negative 0.42, negative 0.26. Okay, you should be getting negative 170. Don't forget your unit. Alright, so I hope that helps for question number 2. Now, last question is on nodal analysis. Now, nodal analysis, mesh analysis, those are the two like sacred method that you need to know at least, okay, for your circuit analysis, for your electric circuit, I mean. Okay, now the third question says verify your answer using nodal analysis. Now I think only one student, okay, did nodal analysis first before doing superposition. Doesn't matter. It doesn't matter. So if you are in an exam setting where you have to where you have your answer script, you can answer any questions first. Am I right? You can just, but make sure you just have to number your question in your answer book. So actually it's up to the student. So if you ask me, which method would I do first? If I am very like super confident with nodal analysis, I'll definitely do nodal analysis first, even though the questions comes after superposition. Okay, so if I'm not so I'm not so sure about my superposition, but I'm very sure about my nodal analysis, I will do my nodal analysis, get the number first, and then do my superposition. Okay, but that is of course only works if you are very already confirmed that you are good with your nodal analysis. All right, now I mentioned to you I ask questions that test your understanding. I love to ask questions that test students' understanding, because I really felt that we engineers, we need to understand, we do not memorize. So when I give question, I want to see whether you understand the concept or not. Okay, hence the reason why I deliberately put the 3 down there, to see whether you understand that 3 and 2, they're connected in series. Okay, those are the things that I actually see when I do the quiz question. Alright, now for this question, nodal analysis, V1 and V2, that one is the ground over there. Okay, now note 1. Now, oh yeah, before I even write note 1, I have to answer this question. A lot of you did nodal, a supernode. A lot of you did supernode. That's when everything goes wrong. Okay, I want you to put a note. Let us put a note, a recap note. Please remember, you only do supernode, you can only see supernode if there is a voltage source, whether dependent or independent voltage source, okay, connected in between two non-reference essential node. This is important, essential node. Okay, so those of you who do a supernode, is because you get confused with this. That is not an essential node. That is just a node. Okay. Alright. So when you do this, you take this as an essential node. That is when your analysis goes wrong. Okay. So how to do it? Let us do together. It is not supernode. Please remember. Okay. Non-reference means it is not connected. If V2 is here, so if let's say V2 is over here, so definitely if let's say we have like a voltage source, this 2 ampere here is a voltage source. Okay, let me just delete that. Let me rephrase. If 2 ampere is a voltage source, if 2 ampere is a voltage source, it's still not a supernode because it is connected to a reference point. Alright, I hope it is clear. Now, it is not a supernode because this voltage source is not connected to two non-reference essential node. It is only connected to one non-reference essential node. That here is just a node. Okay, now let's do node 1. Node 1. Okay, this one is another mistake. For some reason, remember we do current branching out. Okay, so a lot of the question you did, the current is going that way, and so you do -2. But in this case, I deliberately put the current going out. Again, I'm checking your understanding. So that is actually current branching out. So those of you who didn't get full mark for your nodal analysis is because what you did was you get your equation wrong by putting it as -2. When it is actually current branching out. Okay, so it's actually -2. It's actually just 2. No, oh my gosh, this is the third time. Salah aja. I think I need to eat. I need my chocolate. Oh, so it's just 2. Alright. I hope I didn't confuse you. Alright, now this one here is 2 because it's also current branching out. Okay, now I'm here. So I'm here is Many of you get this one correct. Alhamdulillah. Next come the tricky one. This one here. Those of you who do supernode is one problem. Another one who didn't do supernode, okay, you've forgotten one point. I think I did one example on this. I really hope you scurry that node and then look back into the node. So this bit here is actually V1. Remember, you have to find the effective voltage, isn't it? You do I equals to the V effective over the resistor. Alright, what is V effective? You have to always minus. So it's always V1 minus something at node 1. So it's V1 minus, and then you see the positive sign first. It's a positive sign there. So it's always minus. You always do V1 minus 0 over 5. In this case, it's V1 minus something. So it's V1 minus. Here you see the positive sign first. Then minus V2 over what resistor? Over 2 equal to 0. Okay, now then come the next problem with doing this node analysis. For some reason, again, I do not know why. Okay, those of you who try to kill off the denominator did poorly in selecting what to multiply. Okay, another one didn't care about denominator, so it's fine. You just want to keep it in fraction is fine because your calculator can do that. So those of you who actually do fraction, okay, and you want to kill the denominator, the best is actually killing it off by multiplying with 10. So you will get 20 plus, that one is 2 now, 2v1, and then you have plus 5v1. Now there's a 5 over here. Let me just put the hidden 5. Then there's a 10. And do this 5. Am I right? Okay, in case you didn't see that. Alright. So azan. Let me just finish this. Bismillah. And then minus that one, 5 times minus 4 is minus 20. Minus 5v2 equals to 0. Simplify that. Okay, and then you see that 20 kills each other, then you only get 7v1 minus 5v2 equals to 0. This is your first equation. Now I'm just going to pause there for a bit until the azan completed. Alright, so we got the first equation. Now to the next equation. Let me just take that circuit there. Now we're going to node 2. Now, remember node 2, we always want to find the effective over the R. I want you to remember this. So now at node 2, again we are looking at current branching out. Let us do this one first. Okay, so it will be V2 minus 5. Now over the resistors connected in series. In fact, if I want to do this, it's actually V2 minus positive 5 minus 0 if you really want to understand the concept of V effective. And I'm just going to put it down for you to understand that. Over the resistor 5 plus, now I'm down here, plus, and then it's V2 minus 0 over 5 plus, now here this bit here, V2 is always V2 minus something. When you find V effective, you always have to do V2 minus something. When you're at node 2, V2 minus something. If you're at node 1, V1 minus something. When you're doing current branching out. Okay, because we are doing current branching out. So V2 minus, you see the negative sign first this time. Minus negative 4 minus V1 over the resistor of 2 equal to 0. So it is not a supernode. Okay, it's not a supernode. Alright. It is just normal nodal analysis. Alright, so if you multiply everything again with 10, okay, quickly you will get 2v1, okay, 2v1 minus 10 over there, and then that one is plus 2v2, and how about that one there? Okay, plus 5v2, that's minus positive so positive 20, and then you have minus 5v1 equals to 0. Okay, and then you just have to group it up. There you have it. Yep, this one is v2. Sorry, that's the fourth time again. Ya Allah Akbar. Okay, we need to relax now. Bangun tahajud lebih sikit ni. So let me just correct that. So that one, that is 2v2, not v1. Alright, so leaving me only one, that is a minus 5v1, and then v2, and v2, that is plus 9v2. This one here, now you have this bit here is negative 10, this one is 20, minus 10 plus 20, positive 10, bring it on the right hand side, you will get negative 10. So this is your second equation. Now what do you have to do? You just plug into your calculator. You have to plug into your calculator. Your first equation, what was it again? It is 7v1. Okay, 7v1 minus 5v2 equals to 0. That's the first equation. And then you have the second equation, just like the one that we did. It's minus 5v1 plus, I think it was 9. Yep. Plus 9v2 equals to negative 10. Once you plug into your calculator, you will get v1 equals to negative 1.32 volt. And you get your v2 equals to negative 1.04 volt. Alright. Now, the question says what? Using nodal analysis, verify your answer, your I naught. Alright, so what is I naught? Now, a lot of you get the mistake getting the equation. Some of you get the equation. So I naught is basically the current here, which is basically just V1 minus 4 minus V2 over 2. So this is in fact your I naught. Alright, so you plug into your calculator. Okay, so you do minus 1.32 minus 4, and then minus 1.04. Don't forget to divide by 2. Okay, you should be getting negative 1.73 ampere. Alright, so with that, we complete your quiz solution for quiz number 2. Alright, I want you to, those of you who didn't get it, I want you to try to attempt to do it again. Alright, thank you students.